Distinguish between isotopes and isobars, giving one example for each. Second part, why is the mass of a nucleus always less than the sum of the masses of its constituents? Write one example to satisfy your answer. Coming to the first part of the question, differentiate between the isotopes and isobars. Here, isotopes have same atomic number, but isobars have same mass number. Okay, by giving the examples, we can easily understand this. For example, isotopes here, carbon 12, it is 12C6, carbon 13 is 13C6, carbon 14 is 14C6. So here, the atomic number, it is the same. So this is what we call as isotopes. Atomic number of all it is same, 6, 6, 6. This is the isotopes. Isobar examples are, here take the different elements. Sulfur 40C16, chlorine 40Cl17, argon 40S18. Here the mass number is same. That is the 40 is the mass number that is same. So in this way we can easily differentiate the isotopes and isobars. Coming to the second part, the mass of nucleus is less than its constituents because in the bound state, some mass is converted into binding energy, which is energy equivalent of mass defect. Example, mass of 16OH nucleus is less than the sum of masses of 8 protons and 8 neutrons. Classify the following 6 nucleons into isotones, isotopes, and isobars. What is isotones here? Isotones means the nuclei that contain the same number of neutrons but are different in their number of protons. Okay, if you observe here, isotones Hg, that is 198 and 80. 80 is the number of protons, but 118 is the neutron. And Au 79 is the proton, and same 118 is the neutrons. Coming to the isotones is the atomic number is the same. That is what we call as isotopes. Example, for the carbon, also atomic number is the same. 6 is the atomic number, but this is the carbon 1 and this is the carbon 14. Isobars, atomic mass is the same. Here, the mass is 3 for helium and hydrogen, but the protons are 2 and 1. Okay, in this way, we can easily classify the isotones, isotopes, and isobars. Coming to the second part, how does the size of a nucleus depend on its mass number? Hence explain why the density of nuclear matters should be independent of the size of the nucleus. Okay, here first we can find the volume, radius of the nucleus. Radius of the nucleus is given by R is equal to R naught times A to the power of 1 by 3. This is the radius, where R naught is the constant value. And volume of the nucleus, that is V is equal to, we know that 4 by 3 times pi into R cube. Okay. And if you are going to substitute this value, then volume becomes 4 by 3 times pi into R value is R naught into A to the power of 1 by 3 whole cube. This is the volume. Okay, and we can write here the A, it is a separate. Then we can write this one as 4 by 3 times pi into R naught to the power of 3 times A. Okay, where M be the average mass of the nucleus, then the mass of the nucleus is equal to, that is mass is equal to M into A. And nuclear density is equal to, we know that mass by volume. Mass is equal to M into A and volume is equal to 4 by 3 times pi into R naught to the power of 3 times A. Then AA will get cancelled. Then this becomes, your denominator will go to the numerator. Then this becomes 3 times M divided by 4 pi R naught cube. So this is the nuclear density. Then we can easily say that nuclear density is independent of the size of the nucleus.